Hello everyone. This is going to be the first video on trigonometry that I'll be uploading to a YouTube channel. We have already discussed about the associated acute angle when it comes to angle trigonometric ratios of angles more than 90 degrees. So we can generalize that for any angles in the future. In the next video I'll be talking about generalizing trigonometric ratios for any angle. Basically last week we looked at angles within 360 degrees in the range of 360 degrees. Okay, but we left out few details there, and I said that I'll be doing a video on this. So in the last class we discussed about 180 180 minus theta, 180 plus theta, then 360 minus theta and 360 plus theta. So these are the associated acute angles. This portion would be 180 minus theta, this portion would be 180 plus theta, this portion would be 360 plus theta, this portion would be 360 minus theta, right? Other than that, these angles, these associated acute angles were taken with reference to the x-axis, but in this video we're going to look at how to find associated acute angle with respect to y-axis. So y-axis is the line which is associated with here positive axis 90 degrees, the smallest angle. Okay, we'll look at this. Look at this triangle ACB, the triangle ACB, and I have taken CB as A, AB as C, and AC as B. These are the sides, and the angle I'm taking theta here is this angle, right? So for this angle we can write down the trigonometric ratios. Sin theta is the opposite side divided by hypotenuse. In this case opposite side is B divided by C. Cos theta is adjacent divided by C, and tan theta is B divided by C. Now also we can define trigonometric ratios for the other angle. So this is a right angle triangle. If this is theta, this would be 90 minus theta. We can also call this 5 by 2 minus theta, right? Same thing, huh? This is in radian, this is in degrees. So sine 90 minus theta, if you take sine 90 minus theta, opposite side would be CB and hypotenuse C. So opposite side would be A over C. For cos theta, adjacent side would be B, so B over C. Tan 90 minus theta, tan of 90 minus theta, tan is opposite side divided by adjacent A over B. Okay, let's see whether there are any relations between these two trig ratios. If you take sine 90 minus theta, this ratio A over C is equal to cos theta here, right? A over C is equal to cos theta here, so we can write this as cos theta. Cos 90 minus theta, the ratio of this is equal to B over C. Now where is B over C? B over C is here. B over C is equal to sine of theta, and tan 90 minus theta, A over B, but we don't have any A over B here, so this should be a B over A. Yeah. We don't have any A over B here, but instead we have B over A, so which means this is equal to 1 over tan theta. So we all know what is 1 over tan theta. This is equal to cot theta. Notice this, In the previous case, we will take 180 minus theta, 100 plus 80 plus theta. So in this case, 180 plus or minus theta, or 360 plus or minus theta. The trig ratios did not change. The trig functions did not change. Ratios are equal. The trig functions did not change. Sine 180 plus or minus theta is equal to sine theta plus or minus or plus. Sorry, minus or plus. Notice this sine, the function did not change, but when you take 90 minus theta with respect to y-axis, you can see here that there's a change of the function. Sine becomes cosine, cosine becomes sine, and tan become cotangent. So we have to keep this in mind because this is very useful when we are dealing with trigonometric identities. Okay, let's go to the other detail where we can represent any angle in the second quadrant with respect to y-axis. Okay, in this case, like the last time, I have made a construction. So here at first we take an acute angle in the first quadrant. This is at P1 x comma y, and then since we are going to tackle this problem using angles with respect to y-axis, so I'm going to construct a right angle triangle here in this. As you can see here, the right angle triangle is constructed such as OAP1 triangle is congruent with OCP2 triangle. Okay, OAP1 triangle is congruent with OCP2 triangle. So OAP1 triangle is congruent with OCP2 triangle. Okay, which you will see why in a minute. So if these two triangles are congruent to each other, their sides are equal. So in this case, if the coordinate of P1 is x comma y, so y is being this, so here this should be equal to P2C. So P2C is in the x direction now. P2C is in the x direction now. Since this is in the second quadrant, the next coordinate is negative, so we'll write it as minus y. Now when you look at P1 coordinate, the y coordinate of P1 is y, sorry, x coordinate. Now we'll look at x coordinate. So OA is x. That means OC is also x. OC is also x. OC is the y coordinate of P2, so we can write x here. Now all we need to define the trigonometric ratios for this point is the coordinates. We have found the coordinates. Now we can write the relevant ratios. So sine 90 plus theta, so this is where we are now in the second quadrant. So we can represent this angle like this, 90 plus theta. So here this is 90 degrees and here we have theta, so this would be 90 plus theta anti-clockwise. The sine 90 plus theta, you know, sine function is defined as the y coordinate divided by 1, since we are looking at a unit circle. So y coordinate here is now x. Y coordinate here is x. What about cos 90 plus theta? Cos is defined as the x coordinate. Now the x coordinate here is given as my y. Sorry. What about tan theta? Tan theta is y coordinate divided by x coordinate. So x divided by minus y, so we can write minus like this. Okay, so for p2 minus y x, this is the coordinate. Let's look at any relevances between these trigonometric ratios and trig ratios for the function at p1. Okay, x, what is x equal to? X is equal to cosine theta. So this is equal to cosine theta. Cos 90 plus theta is equal to minus y. So in this case, minus y is equal to sine theta. So we can write as sine theta. Tan theta is equal to y over x. Hence tan 90 plus theta is equal to minus 1 over tan theta. So 1 over tan theta is cot theta. You can see here that the sign change still applies. It doesn't change. The quadrant rule still applies to this as well, but the function has changed. Here the sine of 90 plus theta is equal to the cosine of theta. In the 180 plus or minus case and 360 plus or minus case, you saw that the trig functions did not change. But in this case, when we are taking the acute angle with respect to y-axis, the function changes. So you have to memorize these, because these are very important when it comes to trig identities. So in summary, sine 90 minus theta is equal to cosine theta. Cosine of 90 minus theta is equal to sine theta. Tan 90 minus theta is equal to cot theta, and also cosine theta is equal to sine of 90 plus theta. Sine theta is equal to cosine of 90 minus plus theta. So sine theta is equal to minus cosine of 90 plus theta, and cot theta is equal to minus tan 90 plus theta. Right? So please try to memorize these things before the next class. Okay, thank you.